A whole new area in Stage version 2 is the projector. The projector object holds many settings and offers us a projection-specific drawing. Let's have a look into the different lines. Starting with the target line with the distance of the focus point. The cone lines and the view area can get separate colors. Additionally, we can draw a cross and a zoom range in relation to the lens. In the next group, we have settings for a line for soft edge. We can adjust the vertical and horizontal soft edge separately with a separate color. Like normal fixtures, we have a controller tab with the brightness channel, the image source and settings for the focus distance. If we change the focus point, we see the response in the viewport, and we can also use the handles to drag that or even change the lens with the hands on the side. In this case, we have defined a zoom lens, so the range will limit us. The projector tab holds the necessary information like the aspect ratio, panel and the ANSI lumen, which affects the brightness of the image. The gain factor will be used in the calculation. The drop-down helps us to get the often used standards, and we see the change right in the viewport. The lens group holds these settings with an additional lens shift. If the projector holds the necessary information, you can use the lens chooser and get a list of available lenses for these Panasonic projectors. A click will change the lens and also the zoom range, so we can drag between 2.6 and 5.1. The selected lens will also change the possible lens shift range. A nice option is to define a target, like our cube in the scene. We can focus on the object. We can also calculate the necessary lens to cover the whole 3D object. So in this case we should need a 0.56. To get the results with available lenses, we use the next command. I move the projector a bit back to get in the range of the listed lenses, and now it pre-selects the 1.0 to 1.2 lens to cover that object and set the focus point on that object. Another area is the Analyze. It shows us the image width, image height, diagonal, the pixel size and the calculated lux value with relation to the gain factor and ANSI lumen of the projector. To use the minimum and maximum values, we are able to get a measurement grid with several measurement points on the surface of our target object. We see this distance, pixel size and brightness of every hitting point. Let's rotate our cube and update the calculation to show the different used distance values with corresponding brightnesses. The grid could be helpful for mapping on 3D objects. Now we get the minimum, maximum and average values in the analysis.